Find the vector equation of the line L1. Here is line L1, and we want the vector equation of that passing to the point 2, 5, which is our point A, which we need a point to start with, and parallel to this vector 3i minus 4j. Well, we know that vector r is equal to vector OA plus some vector parallel to 3i minus 4j. So it's going to be AP. Alright? Well, vector r is equal to, what's the position vector of point A? Well, if the point is 2, 5, then our vector is over 2 in the x direction and up 5. Plus, well, our vector going down this way, we know we have to go over 3 and down 4 because it's 3i minus 4j. So we say this is 3, negative 4. Well, I don't know how far I'm going to go down. It's going to be parallel to this one, but I don't know if it's exactly 3i and 4j, so I'm going to multiply by some constant. I don't know. It could be bigger or smaller, but this is some proportion of that. Well, sometimes you see this written as x comma y is equal to 2 over 5 plus lambda 3 negative 4. Alternatively, you may see something like this. We could also write this as xy is equal to 2i plus 5j plus lambda times 3i plus a negative 4j. You may also see this written as r is equal to 2i plus 5j, which is that starting point, plus lambda times 3i minus 4j. You could see it like this. Most often you see it like this. Sometimes they put r, sometimes they put xy. The important thing is this A point is going to give us our first vector, over 2, up 5. And then this, whatever's here, is going to be times lambda, and it's going to tell you how far to go over and how far to go up or down. And that's how we get our vector equation of this line. That's what we're doing, finding a vector equation of line 1. Find the vector equation of line L. This is the black line L right here. We want to find the vector equation of line L passing to the points A, 1, 4, and B, 5, 8. So we know that from 0, 0, our positional vector is going to be 1, 4 to point A. And our positional vector of point B will be 5, 8, or 5, 8 plus 8j, or 1i plus 4j. Give both parametric and Cartesian form of L. Well, here is our key equation. R is equal to A plus lambda B. Here is R, and we can split that up into its components. A plus some proportion, which is lambda, of B. Well, what is B? B is going to tell us how far to go over and how far to go up. Well, we can also look at B in terms of it's the negative of A plus R. If I want to measure B, I have to go from A down to 0, 0 and back up through R. That means I'm going to take the negative of A. This is a key concept. You see this in almost all vector problems like this. That to get vector B from here to here, I have to go the opposite of A plus R. The opposite of A plus R, well, we know A is over 1 up 4, so its vector equation is 1, 4. It's not a vector equation, but its vector is 1, 4. And we know that from 0, 0, this one is 5, 8. So the opposite of 1, 4 plus 5, 8 gives us 4, 4. That's B. And I can now start to fill this in. X, Y, which is the general R, or sometimes you see it written just as R, is equal to A. Well, A is 1, 4 plus lambda times 4, 4. That's the key. Is we have to find B. And how do we find B? We take negative A plus R. Or you could think from 1 to 5, I have to go over 4. From 4 to 8, I have to go up 4. So here is my parametric equation. I have to say x is equal to 1 plus lambda times 4, and y is equal to 4 plus lambda times 4. And I have my parametric equations right there. Here are my parametric equations. X equals 1 plus lambda times 4. Y equals 4 plus lambda times 4. So I can take my x parametric equation and solve for lambda. Minus from each side, divide by 4, and I get x minus 1 divided by 4 equals lambda. And lambda also equals minus 4. I take this parametric equation, minus 4 from both sides, divide by 4. I get lambda equals y minus 4 over 4. So if lambda equals this and lambda equals that, then we can set these things equal to each other. So I have y minus 4 over 4, and they are equal to each other. And this is your Cartesian form of the graph. Notice we have x's and y's. You could also transfer this to y equals mx plus b quite easily. What do I mean by that last part? Well, we've got our Cartesian form here. If I cross multiply 4 times x plus 1 equals 4 times y minus 4, and then I distribute out 4x minus 4, 4y minus 4, I just flipped the whole thing around and added 16 to both sides, then divided by 4, I get y equals x plus 3. This is y equals m of 1, x plus b of 3. Y equals mx plus b. You can easily graph this now. Here's a great question involving vectors. You're given two lines. X minus 2 divided by 4 equals y plus 2 over 3. That's in Cartesian form. And x plus 2 divided by negative 1 equals y minus 4 divided by 2. You could see we could cross multiply and get each of these into y equals mx plus b. But we choose not to do that. We go from Cartesian form from this line to parametric form. Remember, if these two are equal to each other, they're also equal to some constant. For this red one, we'll call the constant lambda. So x minus 2 over 4 equals lambda, and y plus 1 over 3 equals lambda. We can now solve for x. Multiply by 4, add 2. We get x is equal to 2 plus 4 lambda. We can solve for the y. Multiply by 3, subtract 1. We get y equals negative 1 plus 3 lambda. Well, here are our two components of, if this is the Cartesian, this is the parametric form. X over y, 2 over negative 1, and it'll be lambda times 4 and lambda times 3. Here is my parametric form, or these are the two parametric forms, but I can write it like this. In this case, if I have x plus 2 over negative 1 equals y minus 4 over 2, I know they're equal to some constant. I'm not going to use the same constant. This time I'll call it t. X plus 2 divided by negative 1 is equal to t. Multiply by negative 1, subtract 2, and I get this statement. Y minus 4 divided by 2 equals t. Multiply by 2 and add 4, and I get this statement. Well, here's my parametric form. I can write it as x over y is equal to, take your x, it'd be 2 plus t times negative 1. Put your y row below that. This y goes there, this 4 goes there, and it's t times 2. So now I've got my two vector equations of the lines. So now that we've found our two vector equations of our lines, it's critical to note that this is the most important part. Remember, this is your directional vector. It's the b vector. Here is your other directional vector. It's the b vector. And if we want to find the angle between the lines, this is the direction of our line. And this is the direction of our second line. That's the most important part of the equation, is that you know that you're going after this vector, your directional vectors. So what really matters is that our line is parallel to this vector, and our line is parallel to this vector. So we're really concerned with the vector 4, 3, and the vector negative 1, 2, because they are our directional vectors. We're asked to find the angle between the lines. We know that cosine theta is vector A times vector B divided by the product of the magnitudes of the vector. Well, how do I find the dot product or the scalar product? All I have to do is go x1 times x2 plus y1 times y2. Easy multiplication. And how do I find the magnitude? It's just the Pythagorean theorem. 2 squared plus 4 squared is 25. Take the square root and you get the magnitude. Negative 1 squared plus 2 squared is 5. Take the square root and you get that. I'm just taking the Pythagorean theorem of the two. This is the x component and the y component. The x component of the y component. And when that's the case, all I have to do is simplify. This becomes 5 squared roots of 5 on the bottom and 2 on the top. And finally, to answer the question, what is the angle between them? I know that theta is going to equal cosine, the inverse cosine of 5 square roots of 5. And when I do that on my calculator, I wind up with 79 degrees to the closest degree. Find the point of intersection. So we're looking for some x, y point of intersection of the lines line 1 and line 2, whose vector equations. So line 1 has this vector equation, r1 equals 2I plus 3j plus lambda times 2I plus j. And L2 has vector equation r2 equals 5I minus 2j plus this u letter. I could use lambda, or I just use another Greek letter, u times I minus 2j respectively. Well, the first thing I want to do is convert r to a form I'm more comfortable with. 2I plus 3j is written like this, 2 over 3. I know that's x direction, I know that's y component of my vector. Plus lambda times 2I plus j is 2 over 1. I'm more comfortable with this, so that's what I go with. Also, r2 is 5 over negative 2. X component, y component of your first point, plus your directional vector is 1 and over negative 2 in the y direction. Well, here are our vector equations. I want to go to Cartesian form. Cartesian form will allow me to get x's and y's. I know I can do that on the coordinate plane. Well, what does it mean to go to Cartesian form? Well, we have to solve for lambda and solve for the u. Well, I write this as x equals 2 plus lambda times 2. X equals 2 plus lambda times 2. Y equals 3 plus lambda times 1. And solve each for lambda. Lambda equals x minus 2 divided by 2. Lambda equals y minus 3 divided by 1. Over here, I write x equals 5 plus u times 1 and solve for u. X minus 5 divided by 1. I suppose I don't need to divide by 1, but I'm just doing that. And for y equals negative 2 plus u times negative 2. Solve for the u. Add 2 to both sides, divide by negative 2, and we get this expression here. So I solved for lambda, and I solved for u. So we get lambda is x minus 2 over 2, and lambda is y minus 3 over 1. We can set these two equal each other and cross multiply, giving us x minus 2 equals 2 times y minus 3. Distribute out the 2, and then put this x minus 2 equals 2y minus 6 into standard form, which is ax plus by equals c. Do the same thing here. If u equals this and u equals this, well then these two things are equal to each other. Cross multiply negative 2 times the quantity x minus 5 equals y plus 2. Distribute out the negative 2 and then solve for y. Ax plus by equals c. I've got two equations now in standard form, and I can solve. We're asked to find the point of intersection. So let's find the point of intersection between these two lines. So finally, when you get your red equation and your blue equation here, I see that I have x and a negative 2x, and a negative 2y and a y. So I know if I multiply this one by 2, will give me, if I multiply this red equation by 2, I'll get 2x minus 4y equals negative 8, which sets up a cancellation with my x's. And I can now add my y's, get negative 5y equals negative 16. Solve for y, I get y is 16 over 5, or 3 over 3.2. Now I'll substitute back into equation 1. I have x minus 2y equals negative 4. I write it again. I substitute in. I know that y is 3.2, and I'll find that x is equal to 2.4. If x is 2.4 and y is 3.2, here is the point of intersection. As I was asked, what is the point of intersection?